3D printing is gaining more and more exposure and interest among educators, but the question still remains, how can we use 3D printing in the classroom? There are several types of 3D printers. Some use melted plastic, some use lasers to harden liquid resin, still others use lasers to harden powder or cut and glue paper. Almost all printers build up objects one layer at a time, and almost all of them have a major detriment concerning classroom use. Time. The amount of time it takes an object to print is a serious limitation to using 3D printers in real time in a regular classroom. So the question is, what can you do with 3D printers? And that question is very similar to another one I get, which is, what can you do with math? The answer to both is the same. Whatever you want. The sky is the limit. You do have to do things in the right way. You have to use the right type of math. You have to use the right type of printer or filament or whatever restrictions are necessary for your object. But the power to create things customized to what you want to teach is a very powerful tool. The easiest way to infuse objects into the classroom is with demonstrations. We can use 3D printers to make items to use as object lessons or demonstrations in class. Students are able to see and pass around objects, to hold on to something tangible that illustrates the concept that you're trying to talk about in class. For instance, you can use pattern eggs to talk about piecewise functions, where one piece represents the top of the egg, one piece represents the bottom of the egg, another piece are the ridges that go along the egg, with various patterns according to various functions. Another thing that you can do is talk about polar graphs with the BP logo. So if you have the BP logo, one piece of that, you can talk about what polar graph might make that shape and investigate rose curves. How do you get a number of petals that you want, overlapping petals, points at the end, just a lot of things that normally don't come up, but with one object you can bring a lot of these things up and have students ask, how do you get that? Another thing that you can do is talk about composition of functions with something like a picture. If I take a picture and make a black and white image and then use that to create the height on this 3D printed object, you can essentially get a picture just by using a couple of functions, black and white and a height map. You can also use this in calculus, talking about various objects, solids of revolution, and actually have the solids that are revolving. That also gives students a view of what it means to take a function, revolve it around an axis, and look at the discs or washers or various shapes that make up that object. Another thing that you could talk about is gear ratios or angular speed and linear speed, just by looking at how the gears in a card shooter interact with each other. Another way to use 3D objects is with active learning in the classroom. Items can be printed and used with lessons designed by an instructor in an active learning environment. Having students work in groups can cut down on the number of objects to print, but still keep students interacting with each other and with the objects in a much more physical way while solving problems. This puts students in an active role while learning, rather than a passive role. So then angles of depression should go from horizontal down to that line of sight. And same thing, horizontal down to this other line of sight for the other one.
Okay, so these are 90s, right? So we've got these two being 90s. So we've got
And then put one of the sides horizontal. One of these horizontal, kind of like that. And then just rotate that one down until it lines up with this guy up here.
So like both these lines?
Yeah, so that lines up with the stick, and then this lines up with the plane wing edge, horizontal, this way. Alright, something like that.
So there's like 180, and just a line.
Right,
That
yeah.
makes sense.
A final way to incorporate 3D printing is having students participate in designing and creating. In order for students to design and create objects to print on the 3D printer, they need to be able to use CAD software to design their objects. Learning CAD software and having students take the time needed to design an object can be a serious limitation to regular college classrooms that typically have a pretty packed curriculum. Additional lab time or separate classes would probably be needed to incorporate this type of involvement in the current classroom scenarios. Starting in fall, I'll be running a class that provides an introduction to 3D printing with a mathematical perspective. A recent NSF grant I obtained will also help with research on whether or not active learning and additional 3D design classes can help improve success and retention rates for STEM students. One question you might be asking is why try to incorporate 3D printing into the classroom? John Medina in his book Brain Rules gives a dozen rules for surviving and thriving in work, life, and school. Several of these rules are relatable to 3D printing in the classroom. Rule number 4 states, we do not pay attention to boring things. Boring lectures can be associated with any subject, and math is certainly no exception. Medina expounds on this rule by explaining that our memory works by recording the gist of an experience and not the literal record of the experience. So go and make a sketch, and we'll go and label that angle 67. We know the ladder's 20 feet. There's 20. And then which other piece of information do we want to find? He states, this means our heads tend to be filled with the generalized pictures of concepts or events, not with slowly fading minutiae. Mathematics courses typically build upon one another, so being able to recall information from previous courses is essential to success. By incorporating the gist of a lesson into 3D objects that students use or design, we can help focus the pictures and experiences that give a representation of the details we need students to recall later. Medina also suggests incorporating more of the senses in rule number 9. Students are usually given information in a visual and auditory form, but rarely are there other senses used in the classroom. In fact, many students today are given PowerPoint slides or use their cell phones to take pictures of any notes written by the instructor, rather than copying the notes down themselves. According to Medina, there is no question that multiple cues dished up via different senses enhance learning. They speed up responses, increase accuracy, improve stimulation detection, and enrich encoding at the moment of learning. By using active learning with 3D objects, we can integrate auditory, visual, and physical senses into the learning experience. Being able to experience concepts in a multi-sensory fashion can help encode the experience into memory in a richer way. This provides a better chance of the student recalling the information and experience at a time when it is needed again. The last rule in the book is the idea that we are powerful and natural explorers. Some of the fastest learners today are not those with degrees, but those with diapers. Babies learn through active testing and retesting of their environment, not by passive reaction to their environment. Curiosity is one of the best teachers today. By exposing students to new ways of interacting with math, hopefully we can pique their curiosity to begin asking, what if, and begin their own journey of discovery.